Good day everyone, our experiment is all about field density test by sand cone replacement method. It is often required to compare the compacted dry unit weight of soil to the building specifications. The sand cone method is one of the best ways for determining the field unit weight of compaction. In highway construction, the sand cone method is one of the most used ways for conducting field density testing. Using the sand cone replacement method, the primary purpose of the experiment is to estimate the in situ density of natural or compacted soils. This experiment follows ASTM D155600, which is also known as the standard test method for density and unit weight of soil in place by the sand cone method. To simply determine the mass of soil and sand, each equipment was initially weighed in its empty condition. The excavated soil was placed on a tray and dried in an oven to reduce its moisture content. The sand was placed in the excavated areas whole to replace the soil and determine its density. This procedure was conducted thrice to ensure the acquired data was correct and precise. The materials and equipment needed in the laboratory are sand, number 10 sieve, sand cone density apparatus, density plate, trowel, ruler, laboratory oven, digital scale, plastic basin, and lastly the 3 rectangular tin trays.
In this section, I'll go over the steps we took to conduct the experiment on the field density test by sand cone replacement method. First is to obtain approximately 3 trays of sands and place them in the oven maintained at a temperature of 105 degrees Celsius to 110 degrees Celsius. After around 20 minutes, take the sand out of the oven and sieve the sand using a number 10 sieve. Determine the volume of the cylinder and weigh the empty cylinder and record its mass. Remove the top cap of the cylinder and fill the cylinder with specially graded sand up to about 10 mm from the top of the cylinder. Weigh the cylinder filled with sand and record its mass. Place the base plate on the ground where the density is to be determined. Dig a hole of 4 inches deep within the opening of the base plate. The opening size of the hole should be slightly larger than the base plate opening. Make sure that the base plate is not moved while digging the hole. Place the excavated soil in an airtight container and weigh the excavated soil plus the tray and record its mass. Position the metal funnel on the groove of the base plate and the valve was open to let the sand fill the hole. When the sand stopped flowing, immediately close the valve and remove the apparatus from the test hole. Weigh the cylinder and the remaining sand. Record the mass on a data sheet. Salvage sand as much as possible by placing them back on the container. Then lastly, repeat steps 5 to 10 for at least 2 more trials. After getting all the necessary data, the bulk density, moisture content, and dry density of the soil may be determined.
For the data and results, utilizing the data from Table 1 and Table 1.1, the sand density, the bulk density, moisture content, and dry density of the soil sample are determined. To determine the sand density of the soil samples, this formula is used. Mass of sand divided by the volume of the cylinder. In this experiment, the sand density is equal to 6.865 kilograms divided by 0.005 cubic meters is equal to 1,373 kilogram per cubic meter. To determine the bulk density of the soil samples, this formula is used. Mass of excavated soil divided by the volume of the excavated hole. For trial 1, the bulk density is equal to 1,100.31 kilogram per cubic meters. For trial 2, it is equal to 1,077.95 kilograms per cubic meter, and for trial 3, it is equal to 1,089.79 kilogram per cubic meter, and the average bulk density is calculated to be 1,089.35 kilograms per cubic meters. To determine the moisture content, this formula is used. Mass of water divided by the mass of the oven dry soil times 100. For trial 1, the moisture content is equal to 24.91%. For trial 2, it is equal to 17.18%. And for trial 3, it is equal to 20.07%. And the average moisture content is calculated to be 20.72%. And lastly, to determine the dry density of the soil, this formula is used. Bulk density divided by 1 plus the moisture content divided by 100. For trial 1, the dry density is equal to 880.88 kilograms per cubic meter. For trial 2, it is equal to 919.91 kilograms per cubic meter, and for trial 3, it is equal to 907.63 kilogram per cubic meters. And the average dry density is calculated to be 902.81 kilogram per cubic meters.
In this experiment, the ASTM D1556 was applied as the reference standard. This sand cone apparatus was used to determine the in-place density and unit weight of soils. Our experiment's findings are as follows. The average bulk density is 1,089.35 kg per square meter. The average water content is 20.72%, and the average dry density is 902.81 kg per square meter. The aim of this experiment were achieved according to the findings. Now that the sand density has been calibrated, you can convert this weight to volume, and the fields inside compaction is tested using the sand cone method. For the construction of roads and highways, the sand cone method is an essential test. By measuring the material's density, we may determine whether the subbase, the base, or subgrade of a road project conforms with the project specification. It is significantly important because improper soil compaction could lead to uneven pavement settling under loading conditions.